Now said, let's get started. Some of you are still have trouble connecting to the internet, but I have the slides on at least last one. So we'll continue from where we stopped. So we talk about SQL, and we stop, I believe, right here. We talk about this example. How do you consider reserve both a red and green color boat, and simply change this condition from or to and will not work because there are no boats that's color added with both red and green at the same time. So you will get empty set in return. So rather, one way of doing this is you introduce two copies of the same instance of reserve and boat and enforce two joins simultaneously over them. In the first join, you look for red color boats and you join reserve and boat with red color boat. And in the second join instance, you enforce the green color condition. Okay, so that's the idea. Then at the end of the day, you join them together. Or if this keyword intersect is available, you can simply use the intersect and do two separate SQL and find the sailor IDs that appear in both results. That will give you the sailors who reserve both a red and green color boat. Another way to do this is to, here's another example, which is to find sailors who reserve a red but didn't reserve a green color boat. The way you do this is by using the keyword except. So except, exception is the same as difference, right? So in relational algebra, this basically means A minus B, right? It's fairly simple. The next slide, we're going to introduce a really important concept in SQL, which is called nested queries. What a nested query is it allows you to construct SQL using multiple blocks of simpler SQL queries. So for you to work on more sophisticated logic, one way to do that is to use nested queries. In other words, you introduce blocks of SQL statements and using these smaller blocks to construct a bigger, more complex SQL query to find what you want. Here is one example. Name of sailors who reserve both 1 and 3. Of course, in this example, you do not have to use a nested query. Right? But we all know that you can do this using a join. So how do you do that? Well, you can do this by join the sailor table with the reserve table and make sure the reservation is made on both 1 and 3. Okay, so that will solve your problem. But here's another way of doing this using nested query, using nested blocks. So what you do is, in the inner block, this is what we call the inner block. And obviously, the block in the outside is called the outer block. Okay. The inner block, you find the sailor ID who has made a reservation on both 1 and 3. And in the outer block, you simply go through the sailor table and check if the sailor ID match with the set of sailor IDs who reserve both 1 and 3. So one way to think about this is to view this as a nested loop. For each sailor, do this. For each sailor, do this. And how to understand this keyword in? Well, the general syntax for this is as follows. you will have a value, you supply a value by this keyword in and followed by a set. A. But of course, we're dealing with SQL, so this A it could be not just a set, but could be more than a set. In other words, you may have duplicates in this A. Okay, you may have duplicates in this A. And this value to either true or false. In other words, this whole thing is a Boolean expression that returns either true or false. And that works because where clause expects a set of booleans, right? In the end of the day, where clause expects you to return either true or false. Nothing else. Okay? So this works. You return true if this value is in A and false otherwise. Okay? So that's the simple logic of this. So now with that said, you can understand this as a for loop, right? For each sailor, check if the sailor is from this matrix set or not. Where the matrix set is the set of sailor IDs who have made a reservation on 103. Why it is matrix set? Because the same sailor may reserve both 103 multiple times on different days. Okay? But it doesn't really matter because this is always the same as, right? You can prove this. Okay? You can prove this. In other words, set membership is not affected by having duplicates or removing duplicates. What about one sailor who have not reserved both 1 and 3? Well, you use not in. Use not in. Right? Not in is exactly the opposite of what we have just discussed. Okay? Any question on this? Go ahead.
Which of these is more efficient?
Which of this is more efficient? The general rule of thumb is whenever possible, you don't want to use the nested query for efficiency purpose. Why? Because this has to do with how query engine optimize a nested query. And later on in the course, we will study query optimizer, and you will learn that in most commercial query optimizers, they will optimize each block independently. In other words, if you submit a query like this, what will happen is it will optimize this block independently of what you do outside. So in other words, this will be executed as it is in a sub-plan, what we call a sub-plan. And if the query optimizer does a really bad job, what's going to happen is for each sailor, while you iterate through the sailor in the outer block, this will be executed over and over and over again for every single sailor. Even though by inspecting this, we realize that this actually is a constant. And what you should do is execute this once for all the sailors. But since you are doing this independently, there's no way for you to realize that. However, later on, we will also study another component in database called buffer manager. Even if you were to execute this multiple times, once per sailor, chances are the result will be cached in the buffer, and the second time you try to execute this, it's already in the buffer, so it takes no additional cost to do it. And in all this, we will discuss the implication of this in the later discussions. Okay? So now let's focus on what rather than all. Okay. Now there are more nested queries you can write. Another example is exists. Write it down. Again, assuming A is a market set, there's no value ahead of this, so it just exists itself. This returns true or false with the condition false otherwise. Okay? If A is not an empty set, then exists evaluate to true, otherwise evaluate to false. Okay? In other words, set of A must be greater than 0 here. Set of A. Okay? So find the name who reserve both 1 and 3. This is the same query, but we can write it in a different way now. What we do is, again, we iterate through all sailors. So that's a for loop in the outer block. For each sailor, but now what we do is for each sailor, instead of checking whether a sailor ID exists in the set of IDs reserved 1 and 3, what we do is we take the sailor ID of the current sailor and find whether there is any reservation made by the current sailor on 1 and 3 on the fly. On the fly. So we take the current sailor, so this blue color SID is actually from the outer block, which is not defined in the inner block. Rather, it is defined in the outer block. So while we iterate through the sailors, the blue color over there, that the value of that variable change when you go through different sailors. In other words, the results of this inner block join will change as well as you go through different sailors. And all you care is whether this set is empty or not, because all you care is whether you have made a reservation on 1 or 3 or not. I don't really care how many reservations you have made. That's why this exists followed by a set works. This syntax in this particular context will give you what you want. You can also specify not exist, which is simply the other side of this. Okay? And we can also change this query to, let me type it. Okay, there's another thing called unique. Don't confuse this with a keyword that used to be that was used to define candidate key, right? So that's unique will be used for defining a candidate key if it appears as a table constraint or column constraint. But when it is using a SQL statement, it means the following. It's true if false otherwise. Okay? Is this clear? Can someone tell me what this means? Tian. What do you mean true if A is a set? No?
No duplicates. No duplicates.
No duplicates. What's your name?
Daniel.
Daniel. No duplicates. Very good. Because we said A is a market set. Note that set is a special case of market set, right? So set can be viewed as a market set. So I'm further specifying that A must be a set, which means there are no duplicates. Duplicate free. Okay. Speaking of duplicate free, I have a. So when I first learned English, right, I was in Singapore. I went to this campus, NUS, National University of Singapore. It's that smoke-free campus, right? I was just learning my English, picking up my English skill. I said smoke free. That means you can smoke freely on this campus, right? No? So that's literally was my interpretation of what that means for about 6 months. But I didn't smoke, so it didn't get me into trouble, right? But it is confusing, right? When you look at it. So duplicate free doesn't mean you can introduce duplicate free, right? It means free of duplicate. Okay. Okay. Now, so that's unique. So now we understand this. What exactly does this query does? What exactly does this query do? Okay.
Finds all the sailors who has reserved this particular boat time.
Finds
the unique ones.
The unique ones. What do you mean?
All the sailors.
If you return a set, so basically it checks for sailors who have reserved that port only once and not twice.
Okay. What's your name?
Sorry?
What's your name?
Nisha.
Say again?
Nisha.
Nisha?
Yeah.
Okay. He's right? Find sailor who reserved this boat only once. Not only once, exactly once, because okay, if A is an empty set, unique A will be false as well. But of course, this is according to my definition. Different database system may interpret this differently. Because unique over empty, how do you consider something empty, whether it's unique or not? This is really a philosophy problem. It goes beyond what computer scientists or anyone can answer, right? In other words, do you consider the universe sparse or the universe dense? Both argument goes, right? The universe is sparse because travel from Earth to Sun take I don't know how many light years. So in that sense, it's sparse. But if you look at the number of stars we have, like billions of stars in this, so it must be dense. So both argument goes, right? So whether an empty set is unique, that's really a philosophy problem. You should go ask, I don't know, a monk or something. Not, I can't answer that. But in my definition, if I define A as an empty set, then what I said just now is right. This one, the sailor who reserved both 1 and 3 exactly once. Not just at most once. Okay. All right. Next, we also have
in the previous ones, if it is not able to find any set that matches the subquery, how does it interpret?
Say again.
If it does not find any set that matches the subquery,
Doesn't find any set match.
Any record that matches the subquery.
Well, then it returns empty set, right?
Right.
Then,
So
in my definition, unique over empty is false.
it's false.
That's why you have to reserve at least one vote. And then at the same time, you can reserve at most one vote. At least one, and at most one give you exactly. Okay. More on set operations. I think that's pretty much all. I mean, the only thing we haven't covered is a value followed by an operator followed by any with a multiset. How to interpret this? Again, it's true or false, right? What this means, there should be at least one element of A to make this expression evaluate to true. Then this whole thing is true. Otherwise, it's false. In other words, you can find no elements in A to satisfy this expression, then it becomes false. Okay? there's another thing called same definition, but all. Okay? Then what that means is for any. That's why this any and all is confusing, right? Because when you say for any student, you must get a 4.0 GPA. What does it mean? For any one of you or for all of you, right? It's confusing, right? In SQL, any means for any one of you. So for at least one of you. And what about all? Then you use all, right? So what this means is it's defined as follows, right? For any x in A, this expression must be true in order for the expression on top to be true. Okay? So let's look at some examples. I want to find a sailor whose rating is greater than that of some sailor called Horatio. Right? You don't have to be better than all the sailors named Horatio. You just need to be better than at least one of the sailors named Horatio. That's what you do. Okay? What about if you must be better than all of the sailors named Horatio? You change this to all. Okay? Based on our definition over there. That's pretty much our discussion on necessary queries. Next, we're gonna discuss division, right? We talked about division. A divided by B, right? So what is A divided by B?
I have a question.
Yeah.
So any and all, I usually don't find them in constant sequence. I haven't seen it.
Can you elaborate a little bit more of your
I haven't
question?
seen it used like in articles. They're not implemented, for example.
Not all the features will be supported by all database engines, right? If you don't have something like this, you will have something similar to this. Okay? Make sense?
Because I mean, you can compare it using some.
Sorry? You can either they have some keyword that does something similar to this, or you do this where using a UDF. I'm not sure about the particular version of Oracle or whatever this you are talking about, whether they have support for this or not, but typically this is not going to be an issue, right? Because these are so fundamental operations that I suspect most database vendors will have something in place for expressing something similar to this. Okay? Now, A divided by B, what is this? That's the definition, right? That's the definition. So how do we express this in SQL? How do we express this in SQL? Well, give you an example. Find SID of sailor who reserve both. Oh, not this, sorry. Find sailors who reserve all boats. Find sailors who reserve all boats. And we talk about how to do this in relational algebra. I'll give you all the sailor IDs. If you want to find the names, you just take the whole thing, natural drawn with sailors, and then figure out the name. But if you just want the sailor ID, this is good enough already, right? So how do we express the same thing in SQL? Well, this is what you do, right? This is one of the ways to do it using nested query. In this case, we use this double negation logic. The idea is you want to find all the sailors such that there's no boat he or she has not reserved. If that's the case, you must have reserved all boats, right? So from here to here, what they give you is any boat that the current sailor has not reserved. So the outermost block iterates through the sailor, right? So imagine you are at a particular iteration of the outermost block. So you are looking at a particular sailor. Let's say you are looking at the second sailor. You are at the second iteration of the outermost block. You are at the second sailor. From here to here, all the way to the end. What I gave you is the boat the current sailor hasn't reserved yet. And all you need to do is to write SQL for this. And how do you do that? Well, you iterate through the boat. When can we be sure that this boat has not been reserved by the current sailor? Well, when there is no reservation record showing that the current sailor has reserved the current boat, which is you find the boat ID from the reserve. Actually, this doesn't have to be boat ID. This can be a heuristic. The whole reservation record, or anything that's part of the reservation record will work. From the reservation, you check if the boat ID of the reservation equal to the current boat. Note that this is from here, and the reservation sailor ID is equal to the current sailor, which is from here. And what this gives you is the set of reservations made by the current sailor on the current boat. It could be one, could be more than one, or could be zero, right? Maybe that the current sailor reserved the current boat multiple times on different days, or only once, or 0 times. Doesn't matter. At the end of the day, only if the current sailor has never reserved the current boat, this will be an empty set. Otherwise, this will always be a non-empty set. Which means not exist will be true. You follow me? Not exist will be true if this is an empty set, meaning that there's no boat. You follow me? There is no reservation record for the current sailor on the current boat, which means I will not return the current boat. When I go through all the boats, and this is true for every single boat, then I return nothing here. Now this means this sailor has reserved all boats, because there's no boat that he or she has not reserved yet. Okay? This does take some time to digest, but I think that ought to explain what's going on. You can go back and review it. All right. The summary, let's skip this. Next, let's look at, those are basic SQL. Let's look at some of the advanced features. One thing we're going to look at is aggregation queries. So aggregation, one thing we noticed that from relational algebra is that it does not support aggregation. Right? For example, number of times you have reserved a boat. How many boats you have reserved in total? Right? What's the total salary of all university employees? There's no way for you to do that in relational algebra based on the things we have learned. In SQL, of course, you can do things like this. You just use basic aggregation operators. You use count, sum, average, max, and mean. Those are some basic ones. I'll give you a simple example. Count the number of sailors I have. Calculate the average age of sailors whose rating equals to 10. What about count distinct rating? What does that mean? Well, what this means is for all the sailors named at Bob, how many distinct rating values they have collected, they have received, rather than just count sailor rating. If I remove distinct, what happens here? This essentially counts what? Total number of sailors named at Bob. That's it. Doesn't matter what you supply here. Whether it's rating or heuristic or name or whatever, it simply gives you a count of number of sailors named at Bob. But now with distinct rating, so I could have things like this. 0.1 Bob, rating 7, 0.2 Bob, rating 8, 0.3 Bob, rating 7. So if I do count rating, my answer is 3. Count distinct rating, my answer will be 2. And if you do count heuristic, it will be 3, count ID will be 3, count whatever will be 3. You follow me? But once you add a distinct to a specific set of columns, that changes the whole semantic of your query, right? The same argument goes for sum distinct. Meaning, before you apply the sum aggregation, you remove duplicates first. Then you do the aggregation. A mean and max, we notice that there's no distinct added to them. That's the reason. The reason for that is adding distinct to mean or max has no effect whatsoever. Your max is going to be 100 no matter how many hundreds you have. Your mean going to be 0 no matter how many zeros you have. If 100 and 0 are the max and mean values in your set respectively. Okay? Now, with aggregation operator, there are some interesting results that we need to go over. How do we find the name of, let's say, oldest sailor? The name of the older sailor, or name of the younger sailor. How do you do that? Well, you may be tempted of doing the following. This could be it looks like a reasonable answer, which is, well, you want the older sailor, right? So must be the one with maximum age. And then I put out the name from sailors. Is this right or wrong? Jonathan, you said no. Why?
Because it messes up with the aggregate function. There's no way to find a max on the name.
Max on the name. Okay. Well, no, I asked the question the other way. What will be the output of this code? What will be the output? I'm asking Jonathan.
Usually when I type that, it just gives me an error. So
You got an error? Okay, answer 1 is you got an error. Okay, let's try this. Let's see what we get. Okay, you can see my playlist. Whenever I click on this, it changes my.
what would be the maximum age for each name?
So they do have age. Okay, let's type this. All right, ready to go. Can you see? Before I go, let me try to collect one more answer. Who want to try? Error, right? Error is 1.
It might pick the maximum age for every name.
Okay, in my guess, okay, I want definitely answer. We're not dealing with a probabilistic database, right? So the answer is only.
Will it just be a table of the names and then it'll have like the max age of the whole table?
That's what he said, right? That's what Jonathan's second attempt. Name of each sailor and the max age augmented to each of these name values, right? Let's see what we get. Well, you do get it. That's not because. Okay, what do you get? You got this. let's try this. Okay. Okay. When I remember the name of this record, Jacobs. Okay. I need to. They do not match. You see? Can you see? Let me turn off the light. They do not match. Okay? Which means this is wrong. Okay? You follow me? And it doesn't match with what Jonathan and Jacob has suggested.
So it's just choosing a random name?
Yes. Yes. Choose a random name. The first one, the database gets. First one, database gets. Why this is the case? Because we go back to the evaluation of.
So basically, sir, it's going to each record and it's only comparing one field with the same field.
Well, let me try to explain this first, then we'll get back to you. Right? Okay, we go back to the basics. How do you evaluate SQL query? Form the cross product from the from clause. There's only one relation list in the from clause, so it's just itself, which is the student table itself. Go through the record one by one, evaluate the where clause, and do the projection if necessary. Right? You follow me? The only thing different here is I'm doing an aggregation first. Once I form the cross product for relations in the from clause, I do the aggregation over the cross product. In this case, the student table itself. Aggregation, the effect of aggregation is turning a set into a single record. So no matter how many records you have in the student table, I will make sure to produce only one record as output. That already tells you the second attempt is wrong as well. Because what you are thinking is go through record one by one in the cross product, apply the aggregation on a record level basis. Well, aggregation is always applied on a table-wise basis rather than record level basis. That's why you don't get 99 argument with each name. If it's aggregation done by record level, what you said would be right, but it is not a record level operation. It's a table level operation. Okay, so that explains why we only have one record. Max age is easy, right? From this cross product, I found the maximum age, 99. That's right. What about the name? Well, when you have a projection attribute side by side by aggregation attribute, most database systems, this goes to how a database implement this, right? So it could be different from vendors to vendors. But most database systems, what they will do is view this attribute, which is a projection, as an aggregation of whatever is the first record it encounters. So you simply take the first record it encountered and project it out. So you see the first record is Jacob. If I limit the results to 1, to enable you to see it, right? Okay, now this explains what's going on. Do you follow me? All right. So in exam, when you ask a question like this, remember this demo. Because in my past teaching, no matter how many times I go over this, and if I give you an identical question in the midterm, some of you will still write this. Okay?
So if we wanted to have, like, if we wanted to augment, like, the names with the max age, like, add that extra
what if that's exactly what you want to do? How do you do that?
Could you add, like, would you add that to the from, like?
So what you will do is, let me see.
Yeah, do like a subquery.
How is your region operator on the max age?
Yeah.
have to do is something like this. I will give you what you follow what I'm trying to do here. Give you a minute. Look at this. Okay. You find the max age and treat it as a separate table, and then do another selection of the max age from the second table and name from the first table, which is student.
So it seems that if we first have an aggregator, then the mini ones would also be aggregated. So like if you only do select names, it was like show all the names.
What you are saying is, what about I do
Like what if the name is
also has the aggregate? Oh, you mean put name first?
Yeah.
Same thing. Doesn't matter. The order doesn't matter. Right?
So it like, but if you only do names, it's not an aggregate, right?
We can try. Same thing. Order doesn't matter in the projection list. Okay. All right. By the way, this is what I expect you to do in exam, right? Like, given a question like this, type it in the next minute also, right? Don't type it in the next hour also. That will not work. Okay. Okay. All right. I think. And that's pretty much about it. And group by and having that's on a separate slide, so we don't need to go on to that. Go on to the next one. By the way, I just realized that our class is supposed to end at 45. I took it like 40, so I've been losing 5 minutes on each of the lectures so far. So just keep that in mind. In case I overrun, that's like we need to check, okay? I have 10 minutes in the back. All right, so same instances, same example. Okay. We talk about basic aggregation, talk about mastery queries, talk about a bunch of other things. The next thing we want to do is this thing called group by and having. What this does is to give you a way to do partition over your SQL statement, right? Over the results of your query, right? So you want to produce some sort of partition. For example, I want to know the total number of students, but not for the whole university, but total number of students from each department. Which means before you do the aggregation, you want to apply a partition on the department first, on the department attribute first, then go from there. And do the same operation over different groups you have obtained from the partition itself, right? So how do you do that? Well, you do it by the group by keyword. Select from where stays the same. You can now add a clause called group by clause, followed by a grouping list. Grouping list is nothing else but a set of attributes from the relation list. Those attributes must be from one of the relations in the relation list. That's all. Okay? And the semantic is very simple. You do your from clause. In other words, you produce a cross product. You do a where clause. You eliminate those records that do not satisfy the where condition. And then, without group by, you proceed to the projection, which is the select clause. But now with group by, what you will do is, after the where clause, you do the group by attribute, or group by clause. You apply the partition, and the partition is defined by the values for those attributes on the grouping list. Then you apply a partition based on the attributes in the grouping list. So for example, group by department ID, that will partition the results based on their department ID values. All the ID value equal to 1 goes to one group, all the ID value equal to 2 goes to the second group, and so on and so forth. What if you have multiple attributes on the grouping list? Well, you view all these values as an element of a set, and you partition the set, multi-set, based on the element value, which could be a pair of values or a triplet, and so on and so forth, depending on how many attributes you have on the grouping list. Okay, that's all. The only subtle thing is what can go to the target list in the select clause. What can go to the target list in the select clause? The basic, the basic intuition behind this is that so after you do your group by, what happens is, so this is after from and where, right? So you eliminate some records, you keep some, this is gone. This is gone, this is okay, this is gone, right? This is after the cross product, you do the where clause. Then what happens to group by? Well, you look at the group by attributes. Maybe there are 2 group by attributes. Based on the value of this, for example, this goes to this group, this goes to another group. So you have 2 groups. You follow me? Right? And finally, you do your select clause, which is projection over this. And what happens is each group will produce one record at output. Each group, no matter what's the size of the group, let me enlarge the group size of the second group. And then both of them go to here. So we have 4 records. This has 2 records. Okay? At the end of the day, regardless how large your group is, each group has 1 record in the output. Produce 1 record in the output. That's a critical observation. Given this observation, the values in this record must be consistent to every record in the group. Otherwise, it makes no sense. How can you use a value that's not consistent with all the records in the group to represent the group? If you group by the department ID, obviously department ID can be in the output because all records in that group must have same department ID values to be end up in the same group in the first place. But if you use name, for example, student name, that doesn't make sense because these 4 students may have totally different names. How can you choose one name as the output to represent 4 of them? You cannot do that. Do all of you follow this argument? With that being said, we now understand the constraint on the target list. You can have 2 types of attributes on your target list. One is any attribute from the grouping list. Why? Because they guarantee to have consistent values for records in the same group. Because that's how they end up in the first group in the first place. Or, what can you do? You can do aggregation. I cannot project out the name, but I can project out the average length of your name. That ought to be a consistent representation for all the records in the same group because I apply aggregation. So no matter how many different value you have, after aggregation, it turns into one single value. You follow me? So target list of a group by query can only have two types of attributes: aggregation or attribute from the grouping list. Let's do an example. For each rating, find the average age of the sailors. How do you do that? Well, that's what you do. From the sailors, you group by the rating and per out the rating and average age. For each rating, find the average of the youngest sailor. For each rating, find the age of the youngest sailor with age greater or equal than 18. Well, before you do the grouping, you can eliminate all the sailors who are younger than 18 years old, because those sailors we do not even consider them. For the remaining sailors, I group by the rating and put out the rating value and the youngest age from each group. That's what I want. Okay. There's conceptual evaluation which I just gone over, so I'm going to skip this, which is essentially what is on the chalkboard. Okay, let's do animation of this using this particular instance. Cross product is just itself because there's only one relation in the from clause. Do the where clause, and in this process I also eliminate unnecessary columns to improve efficiency and to make sure I can draw them on one single slide. Okay. All right. And form groups. So the ratings, the record with the same rating value will be pushed to the same group, like the 2 7s. And then do the final projection. One record per group. There's a typo. This would be 55, or this would be 55.5, but you guys want, right? Okay. Find the number reservation for each right boat. How do we do this? Well, you do a join between reserve and boat, and then do a where clause to make sure you only have red color boats. For the remaining boats and the reservation they match to, you know these are reservations made on the red color boat. Group by boat ID, because now you have to distinguish them by boat ID. They are red colors. And group by boat ID and do a count. That's what you get. Join, reserve, and boats. Make sure it's red color boats. Group by boat ID, count. Okay. Animation of this is, first of all, you do the cross product, and in this process, I eliminate unnecessary columns. What is necessary here? You only need boat ID from boat, color from boat, and boat ID from reserve. That's all you need. You don't need any other information. And do the where clause. In this case, it's very simple. Only one record in the cross product satisfies your where clause. And do the grouping. There's only one group. Count. One group, one count. Simple. Okay. Now, one more thing we want to do is, somehow, in some cases, I may want to have a qualification condition on the grouping results before I do the final projection. But this condition must be applied after the grouping is done and before the projection is performed. So where clause is not good for this, because where clause is performed before the grouping. I'll give you an example. Tell me the number of students from each department, but only for those department has more than 100 students. If you're less than 100 students, I don't really care. Don't report the results back to me. How do you do that? Well, you do this by using this hiding clause. Hiding followed by a condition, and now what this does is introduce something in between of the final projection and and the grouping. You check having right here. And only for those groups that satisfy the result, let's say this does not satisfy, this satisfies. You check the, oops, this design really is not very good, right? Because there's a hole here. We put your eraser here, it may drop like this. I don't know why they come out design like this. To hide the chalkboard. Anyway. Okay. So this will not be in output. This will not be in output. Alright. One thing we need to be clear. For the same reason as we have argued for the select clause, the having clause, the condition you use for the having clause must satisfy certain constraint, which is it must be something that you can really check. You can actually check against the record in the group. In other words, the condition must involve some consistent values from the group. For example, if you group by the department ID and you say having name equal to Feifei, it doesn't make any sense because you can have 100 students in that department, one of them is Feifei, then whether this is true or not, you don't know, right? So for the same reason that we gave for the select clause, to express the condition for the having clause, you can only use either a grouping attribute or an aggregate. Either a grouping attribute or an aggregate. So that each group gives you a consistent view for evaluating that condition in the having clause. Okay? Now, let's look at an example. Find the age of the younger sailor with age 18 for each reading with at least 2 such sailors. So this is the same as the previous example we have seen, except that I add one more condition on the group. I only care about this for a group with at least 2 sailors. For a group with 1 sailor, I don't really care who is the youngest. I don't even want you to be in output. So when you do it, up to the group I is the same as before. But now you do having count greater than 1. So let's run through the example. We do this, This is the same as before. You calculate the condition for the having clause. And you project the final output. In this case, only one goes to the output. Because that's the only group with at least with more than 1 sailor. The other groups will be discarded. Because they only have 1 sailor. Do not satisfy the having clause. They do not satisfy the having clause. Okay? Is that clear? And notice that this sailor got eliminated even before the grouping because the age is less than 18 years old.
So is having basically the same as where in the sense that, so if I took the relation from the first 4 statements, select down to group by, and then above that I said select all from this where count is greater than 1, would that be the same?
Yes. If you don't do having here, you do a alter block, select from this where count is greater than 1, yes.
And do you know if query optimizers can figure that out?
Good question. So, with respect to what I said earlier, you always want to use a single block rather than a nested query to express your query. So, in reality, this will be more efficient for the cross method to work with than what you have set. So write it down on the chalkboard, make sure everyone follows. What Daniel says was the following. I do select. I call CT. From. My from will be from here to here. But in that, I rename this as select reading count start as CP. So I rename this so that I can project it out. Then I do my from, where, and group. So this form a relation for me, which I can use in the from clause of another block, which means I can do a where clause. If you want to be explicit, you can rename this whole thing as T, and say where T dot ct. This will have the same effect as the having clause. Yeah, go.
So, can you actually have aggregate function to have functions?
You can add a UDF function, yes. But you have to write the function yourself.
Okay.
Aggregation is a function, right, if you think about it. But it's just system has defined that for you already.
If you got any group buys, is there any implicit single group that it recognizes already? So does it recognize your output as a single group, and then if you omit the group by, then it just happens on that group?
What do you mean by a single group?
So we just say select. So we have the same query there. So select rating from sailors where age is greater than equal to 18. That will output some schema. Does it? Is there anything where it takes that as an implicit group because there's one thing?
Oh, I see what you're saying. So, well, in that case, what you're saying is, you can think about any select from where this block as if there is a group by here, group by, how do I just say this?
You just put all of the column names.
Oh, not really. Group by something like this. Each record goes to its own group, actually, if you think about it. Because what this select is to go over each record in the front clause and prepare out the output, right? So in some sense, what you're doing is each record in after the where clause is viewed as a group by itself. That's why I group by everything. If you have no duplicates, this will make sure every record goes to its own group. In some sense, but I mean, really, it's you don't have to understand it this way, right? Just think about without group by and with group by. Don't mix them up. Okay? Sure.
So in this case, what would be the grouping pattern?
Grouping, if you group by everything, for example, this will make sure every single record in the student goes to a separate group. Why? Because you are looking at all attributes from the student as your grouping attribute. And since student in the relational schema, which makes sure it's duplicate free, there will be no duplicates in the grouping, right? That's why it's a group by heuristic. But it does not work in the general case because this goes back to the fundamental thing we said. In SQL, an intermediate result can have duplicates. In contrast to in relational algebra, any intermediate result must be a relational instant, which means it must be duplicate free. But if it's a base instant to start with, since this must be a relational instance, must be duplicate free. If you group by all the attributes, this is the same as group by SI. That's the same thing. By the primary key. Do you follow? Of course, one technicality is if you do group by SID, here you can only put out SIDs. You cannot put out anything else. So to make sure this is the same as select from, you should group by heuristic so that you can put out anything, because anything will be a subset of you doing this. But this is really to showing off your skills, right? I mean, why not just do this? Why don't I do that? For the sake of doing it, it's really no point. I mean, I hope you guys can pass that. At one point in my life, I was really proud of doing things like this. Like you see, I can do this, but in retrospect, it's like pointless. Why you want to do that? Now let's look at division again. This is what we said just now, using two negation logic, two nested block. How do we express that without using this? This looks scary, right? I mean, it's like big thing for something simple as simple as A divided by B. Right? This algebra is beautiful, right? And in SQL, you have to write things like this. So waste of bytes, right? Waste of bytes. So can you do this slightly better? Well, with group and having, potentially you can. What we do is find Sailor group with all both. Well, if you think about it, a sailor would have reserved all boats if the number of reservation records for that sailor equal to the total number of boats we have in the database. But you have to be careful because he or she may have reserved the same boat multiple times. By merely looking at the count, it doesn't give you the full picture. But we can fix this by ensuring that the count is over distinct boats that he or she had made reservation for. If that count ends up being the same as total number of boats we have, then there's only one reason for that to happen, which is he or she indeed has reserved all boats. That's what we're going to do. Okay? You join sailor with reserve, and you group by the sailor name and sailor ID. Why you want to group by both? Actually, it's not that hard to figure out. Grouping by sailor name and sailor ID is the same as group by sailor ID. They produce exactly the same group. But why we include this in the grouping list? And for that reason I just explained, you want to make sure this can be used in the final projection list. The name attribute can be used in the final projection list. So it's really just for technicality. We include this as part of the grouping attribute. It doesn't really affect how you do the partition. Well, fundamentally, this is the key and this is the super key. In terms of distinguishing power, super key is as good as a key. But within each group, what do you count? That's important. You count distinct boat ID within each group. What is in each group? All the reservation records by this sailor. All the reservation records made by the same sailor will go to the same group. And then I count distinct number of boat ID from that group. If the distinct number of boat ID from that group equal to the total number of boats I have, well, you must have reserved all the boats. Is that clear? Do you need to add a distinct here? You can, but it's not necessary because this is a base relational instance. It's duplicate free. There's no point of eliminating duplicates from this. But this is really important because if you don't have this, a sailor reserves the same boat. Let's say you have 10 boats in total. If the sailor reserves the same boat 10 times, he or she will be in the output, even though obviously he or she hasn't reserved all boats. Okay. Here's the illustration of that. Okay. No sailor has reserved all boats. That's your cross product. These are the two records in the cross product that satisfy the joint condition. And then you do the group by name and the ID. So you have two groups. Each group, within each group, the distinct count is 1 because each group has only one record anyway, which is both 1, 1 and 1, 2 respectively. We got count 1 and 1 twice for the two groups. But unfortunately, the total number of boats is 4. Well, no sailor reserve all boats. There are also some details about insertion and deletion. Let me quickly run through this. These are less important. I mean, you can probably study this in 10 minutes, 5 minutes from Stack Overflow, right? I mean, there's an interesting article the other day saying that what is computer science? Well, There are many definitions, right? But the many comments. The most popular comment, liked by most repliers over there, is computer science equal Stack Overflow plus Google. There's some truth to it, right? There's some truth to it. All right. So, what is insert into both values? Of course, I shouldn't be saying that. I put my job in jeopardy. So you guys can make sure you raise that one. Insert into both values. If you don't supply a list of attributes, what that goes is the value list will go to the schema in a one-to-one correspondence order. So in other words, this goes to the first attribute of the boat, this goes to the second attribute of the boat, and so on and so forth. If you only want to specify a subset of values for the table you are manipulating with, you can supply a list of attributes and then a one-to-one correspondence of value list. So this goes here, this goes here. What about the name? What about the name attribute, which was not specified in this case? Well, it becomes none. Or whatever default value you have on your column constraint or table constraint. You can also do bulk insert of value from one table into another. For example, like this. Insert into a temporary table with a schema of only boat ID, and where the boat ID is from reserve, where serial ID is 22. What this does is find all the reservations made by serial 22, and find all those boat ID and put that into a temporary table. So that's a bulk insertion. Deletion is very similar to the selection, in the sense that they also rely on a where condition, a where clause. But instead of select from, you do delete from. The semantics is very simple. You delete the record from the affected tables for those records where condition is met. The condition is enforced by the where clause. You can also do update, followed by the table to be updated, using the keyword set with the attribute and the new value and the condition to specify which record to update. And here you can specify more than one attribute value pair. You can you can update multiple columns in one update statement. Null value. There's one thing we overlook at, which is what happens if I have a condition that involves a null value? What happens if I have a condition? Yeah,
I have a question about the previous slide.
Okay, let's go back.
So if in the delete statement, if the selected statement will give you a set, so there are more than one DID.
You mean in the delete?
Yes, in the selected.
If this is not a single, it's a set.
Yes, a set.
Okay. If that's the case, I see what you're saying. So this is, if you want to be really strict about your semantics, some database vendor may reject this, right? Because value equal to a set is not well defined. So what you should really do is change this to in, BID in this. But good catch. I see your point. Do you follow what I'm saying? This is not well defined, right? So change this to double quote. But good catch. Okay? So some system may reject this. Some system may implement this as a convenience for the programmer. Value okay, I know what you mean. You mean in. Okay, let's do it. Okay. Questions? Null value. So three value logic. Null value. So three value logic is true, false, and unknown. What that means is if you have a condition that involves a null value, then in some cases the evaluation could be undefined. What do you mean by, for example, when you say select from student where age equal 18, and you have a student record whose age value has not been specified. So age equal to null. What do you mean by null greater than or equal to 18? Well, this is similar to the example we went over earlier, which is empty set unique. In other sense, this is somewhat a philosophy problem, right? Do you consider null as really big or null as like really small? How do you compare this? Well, the answer is in the formal system we're gonna argue here is unknown. In practical system, it depends on whatever vendor how they actually implement this in their code. You just do a simple test, you figure out what's going on. Okay. Next, we look at the joins. Of course, we've been talking about joins for quite some time. Sure. Okay, I have 3 minutes left. So why not I use this time instead of talking about joins? We're gonna use about 5 minutes, 5 to 10 minutes on Thursday's lecture to wrap up SQL. That's all I want to talk about SQL. Then we move into kernel. So far from beginning of the semester till now is really a review of what you should have already known. But anyway, I think the review is detailed enough. Even if you don't know, even if you didn't know a thing about this before this class, now you have no excuse of not knowing that. Right? Using the remaining 3 minutes, I will quickly show you how to connect to the database server. I promise you we'll set up a database. And you can connect and practice. And in Thursday, I will release homework 2. That will give you a bunch of super queries. Our database server is at okay. And all of you will share a common account. In other words, I expect you to mostly do only selection using this common account rather than creating data, creating tables. And that common database account is this, that's the username. And password is bb at Utah 415. Okay, all small case.
That says solve, right? Not all. Is that second character an S or a 5 on top? No, on top. CS.
This one?
Top.
CS.
Thank you.
Okay? That clear? And the database on this database server, that's our DB server, right? The database you have access to using this account. There are 2 databases you have access to. One is you don't have to write this down. I will make an announcement on the Canvas website too. Okay, so you have access to these 2 databases. Okay? Is that clear? And how you connect to the database? Well, you can either connect using the Unix command line, MySQL client. Okay? Listen. Let me finish. One thing database is multi-threading, which we will talk about later on, but we haven't reached that yet. So until now, we do single thread. Okay. All right. So how do you connect to this? Well, you can connect from anywhere. You can connect using either a Unix, Linux, MySQL client program, and supply the connection string, which I did in the class. And if you're not sure about it, wait for an example from the Canvas website, or just Google it. Or you can use a client program that comes with a GUI interface, like MySQL Workbench. The database server, by the way, is the MySQL database server. So you can use something like a MySQL Workbench. You can download that from MySQL website. It's free, and it has different versions for different OS. And why don't you start playing with these 2 databases? The first one is a small-scale database that mimics a university setting, like has students, professors, and courses, and so on and so forth. The second one is the publication database. And the second one is significantly larger than the first one, has millions and millions of records in it. The first one is the toy database, has only a few hundred records in it. Okay, so you can play with them until Thursday. By Thursday lecture, I will give you a formal written assignment 2 with a number of SQL questions that you will write against these databases. And you will need to produce both the SQL statement and the results.
Did we have a first homework? Did we have a homework 1?
Homework 1 is due on Thursday, right? I did. I released that last week, right? I will release the solution on Thursday. All right.